Hey everybody, David the AI Guide here. Thanks so much for tuning in. Instead of lives on Sunday for a short period here, we are actually going to do something a little different. And there's a reason for that you're going to hear in just a minute. Before we do that though, be sure to follow us on Facebook, Instagram, and Twitter. Also, click the link below, get your free AI resource. The resource is free, everything in the resource is free, and you'll get the opportunity to participate in my beta course, the AI Safe Career Pivot. And you're going to see as we do these videos, because this is number one in a short series, why I'm pushing you to do this, you're about to see. But click that link and get your resource. Also, get my book on Amazon, The Beginner's Guide to AI. It's short, takes 2 to 3 hours to read the whole book, but it'll give you a quick history and current impact of AI on 10 different industries. So check out that book. It's a good short read, and it really lets you know what's going on. But starting right this second, we're going to talk about a seismic shift in AI research that is a true breakthrough. And that is the reason we're going to do a series on this, because it affects everything that's going on with AI. So this is part one again, and let's jump into it. A company in England called Graphcore, which is a British chip designer, and pardon me, I'm going to have to read because some of this stuff is so important, it needs to be read. And let's thank The Economist for sharing this breakthrough. This company, Graphcore, the British chip designer, is creating a computer they call the good computer. They intend to build this over the next few years and have it working by 2025. The name the good computer, The Economist says, is a massive understatement. And here's why. Its design calls for it to carry out 10 to the 19th calculations per second. That's hard to understand what 10 to the 19th means. So what does it mean? Today's laptop can run about 100 billion calculations a second. That's pretty good. It's better than any computer available in the sum of all computers available back in 1996, and we've talked about that. But today's laptop runs at 100 billion calculations a second. The good computer will be 100 million times faster. To put this into perspective, it will be 10 times faster than the number one supercomputer in the world today called Frontier, which is at the Oak Ridge National Laboratory in Tennessee, nicknamed ORNL. And Frontier at ORNL was at the top of the list of the 500 most powerful supercomputers in the world today. And Frontier cost $600 million to build. Think about that. That $600 million is higher than the revenue of probably 98% of the companies that exist in the world today. That's how much was spent on Frontier. So what will the good computer do? Its 4 petabyte memory will hold the equivalent of 2 trillion pages of printed text. What is that? That is a stack of paper high enough to reach the moon. Mind-blowing. Good hardly seems to cut it when you're talking about a computer like this, The Economist says. So why are they calling it the good computer? For those of you who follow this channel, you're going to know what I'm about to say. Jack Good, who worked with Alan Turing as a code breaker during World War II and followed him into computer science, is the namesake of this computer. If you don't know who Alan Turing is, watch video number 1 in my history of AI. It'll lay it all out for you. But Alan Turing is the godfather of artificial intelligence and computing, for that matter, modern computing. So in 1965, Jack Good wrote an influential but off-the-wall article about what the field could lead to. And the article was called Speculations Concerning the First Ultra-Intelligent Machine. And this is exactly what Graphcore is attempting to build. So what does this all mean? This means building and running artificial intelligence models with eye-watering number of parameters. Only 4 years ago, so it's 2022, in 2018, 110 million parameters boasted the game-changing model called BERT. Today's most advanced AI programs in only 4 years are 10,000 times larger, with over 1 trillion parameters. The good computer is targeting 500 trillion parameter models. One of the remarkable things about this growth is that it was wholly unanticipated. There was a widespread belief until very recently that adding parameters made AI algorithms perform worse, not better. This is a true breakthrough. Models like BERT prove that the reverse is true. So the more parameters, the more data you can feed it, the models become better and better. This was a flabbergasting result, says Oren Etzioni, who runs the Allen Institute for AI. In case you don't know who Allen is, he was the co-founder of Microsoft along with Bill Gates. So the head of the Allen Institute for AI should know what he's talking about, and he does. I'll remind you that I did a video probably a year ago about an AI conference from the University of California, Santa Barbara, that featured Oren Etzioni speaking. Again, the belief was the number of parameters in models was reaching the point of no return, meaning that adding parameters would actually hurt performance, not improve it. However, the real breakthrough is that these models exhibit new capabilities that were wholly unanticipated. Doing arithmetic, which a calculator has been able to do for 50 years, but an AI has not, is a side effect of these large parameter models. So Oren Etzioni goes on to say that Microsoft's Florence model and GPT-3, a model by OpenAI, show genuine understanding of the world around them. How about that for a breakthrough? Text-to-image processing is very impressive. Again, at the 2018 Applied Artificial Intelligence Conference in San Francisco, when I went there, Facebook, the head of AI for Facebook, was there talking about how they were still trying to get an algorithm to recognize a cat in a picture. And now we have GPT-3 and Microsoft Florence. Another app called Midjourney was created to create images through artificial intelligence, and this application learns words that go with the images, a wholly unanticipated result. What does this mean? It means that for the first time ever, AR models are flexible, meaning you can use them for many different applications. The entire history of AI is focused on very, very specific applications, and each algorithm is only good for one thing and one thing only. This is a true breakthrough. Stay tuned for part 2. Click the link below, get your free AI resource, and check out my book, The Beginner's Guide to AI, on Amazon. Thanks so much. Part 2 next week.